This function is a rational function because it is a quotient of two polynomials, one in the numerator and one in the denominator. We need to show that this function can be differentiated into this function. So we will use the quotient rule, where we will denote that u is equal to the root x, u dash is equal to 1 over 2 root x. So differentiating root x is usually done so commonly that I remember that it is 1 over 2 root x. But if you wanted to know how to do this, first of all, change root x into power of the half. Now if you differentiate this, you will have to put a half, x to the minus a half, and then once again 1 over 2x to the half, and finally we get what I've already written, 1 over 2 root x. I avoid working through all this, but I just remember that the answer is 1 over 2 root x. And so to continue, I make phi my 1 minus x, and phi dash is equal to minus 1. And the quotient rule says that I need to make it u dash v, take away u v dash over v squared. So I will just substitute these in here, and we'll start with u dash and v, followed by u and v dash. And that'll be 1 over 2 root x multiplied by minus x, take away root x, and multiplied by minus 1. All this must be divided by 1 minus x, and that needs to be squared. You need to be careful here because there is a minus 1 over here, which you need to change that. So I will rewrite this once again. Notice that I've also tidied up that 1 minus x can go right above here. So that's 1 minus x over 2 root x. I changed the minuses, two minuses, into a plus, and I have root x over there. The rest stays the same. So now this part over here is over 2 root x. I would like to change this root x and multiply that also so that I have a common denominator. So if I multiply this, I will have a common denominator. So 1 minus x, and then I need to add root x to root x. This means that if I multiply root x and root x, I will just get x. So I write down plus 2x. Right, now I love my common denominator, which is just 2 root x. And I also have underneath this part 1 minus x. Right, how do I deal with this? I can rewrite this simply by saying 1 minus x plus 2x over 2 root x, and I can fit that 1 minus x in here. Because if you recall, if I have two fractions that are divided by each other, so like this one over here, and I'll put c over a, I can write it similarly, a over b divided by c over a1, which really means that I can now change the sign and just write a over b times 1 over c, which is equal to a over bc. And this is 1 minus x plus 2x becomes 1x over 2 root x 1 minus x all squared, which is what we wanted to show. And this is our gradient function, dy dx, gradient function. Now for the second part, we assess for what values of x is that gradient function 0. Why do we need to know this? Well, this means that when the gradient is 0, that means that there is a horizontal tangent in the original function. What's important about a horizontal tangent is the fact that we can usually find out whether a function has a maximum or a minimum. So frequently we will be asked to find at what points does this happen at all. So when I look at my function, when will this function be 0? Well, it will definitely could be 0 if this denominator, not denominator, the numerator is going to be 0. In other words, it will be 0 when 1 plus x is equal to 0, which means that x must be equal to minus 1. Now we have a problem here because we have a root x in the denominator over here. This root x is problematic because it will mean that really x cannot be equal to minus 1 because root x can never be 0 and it cannot be minus a number. So in other words, x can never be a negative number. Therefore, dy and dx is not defined for x is less than or equal to 0. Hence, dy over dx never equals 0. In other words, our function does not have a horizontal tangent. And we are also asked to find for what values of x is dy dx undefined. When we want to find out when dy dx is undefined, we look at our denominator and we ask ourselves, when is 2 root x 1 minus x squared 0? Because anything over 0 will be undefined. Now our denominator is made up of two products. One is the 2 root x and the other one has a 1 minus x squared. So none of these can be equal to 0. We know that root x cannot be negative or 0. So when x is less than or equal to 0, function is undefined. But note there is another part where the function is undefined when 1 minus x is equal to 0. So, in other words, our function is undefined when x is less than or equal to 0 and when x is minus 1.